Hi, I thought I'd bring a video or teach a video on the ammonia buffer system. It's not really covered in the handout. It's present in the kidney, and so it's another part of acid-base regulation I thought you should know. So, and maybe you didn't get a good review of it in pathophysiology. Maybe you did, I don't know, but I thought I would go over it really quick just to make sure that you had this down. So already present in this is the renal interstitial fluid, proximal tubular cell, and tubular lumen. Oh, one more thing about the ammonia buffer system. It occurs in two places in the kidney. So the first part I'm going to talk about is the proximal tubular cell. The second part I'm going to talk about is what happens in the collecting duct. So here we're talking about the proximal tubular cell. And so we're going to start over here at the renal interstitial fluid. Already present here is glutamine. Why? Glutamine is a breakdown product of amino acid metabolism from the liver, so it's already present in the interstitial fluid. This is easily absorbed, or it is absorbed, into the proximal tubular cell. So it also can come from, if there's already some present in the tubular lumen, it heads over to the cell also. The cell takes it through some metabolic processes and turns it into two bicarb ions and two ammonium ions. These bicarb ions are reabsorbed into the body. So this is a net gain. Bicarb, yay. With ammonium ions, this ends up leaving the proximal tubular cell and heading over to the tubular lumen. And then already present in the tubular lumen is some chloride ion. So this ammonium ends up combining with some chloride. But the bottom line is, out it goes. When this occurs, this is a cation, so there's a cation exchanger, and so sodium heads back into the proximal tubular cell. And so this is the first part of the ammonia buffer system occurring with glutamine. Glutamine, again, coming from the renal interstitial fluid, could come from the tubular lumen also, according to Guyton. The glutamine enters the proximal tubular cell. The main breakdown products are two bicarb ions, two ammonium ions. The two bicarb ions are reabsorbed back into the renal interstitial fluid, which is a net gain of bicarb. The ammonium ions, through a transporter, heads over to the tubular lumen, combining with chloride, and then out it goes, and then sodium comes back in. So in this process, the benefit to the body is the two bicarb ions. So now let's look at what happens when what happens in the collecting duct. So I've got to move the camera, so 1 second. Sorry if this is causing any problems there. All right, in the collecting duct. So already present in the renal interstitial fluid is some CO2. So dissolved CO2 heading across. CO2 is now present within the collecting duct cell. Remember, it's on a gradient, so you can go the other way. But this CO2 will combine with water. And so under the influence of carbonic anhydrase, as we've learned multiple times, carbonic acid, and this generates bicarb ions plus hydrogen ions. So that's part of what's occurring in the collecting duct cell. So this is part of it. So also present in the collecting duct cell is ammonia, not ammonium, so NH3. And this is easily diffuses across the membrane so that it's present here in the tubular lumen. Now the hydrogen ion, there's an ATP pump. ATP pump is the circle. which helps move the hydrogen ion across also. So the hydrogen ion is now here. So the ammonia is combined with the hydrogen ion, and this forms ammonium, NH4+. And this will combine, just like it did in the proximal tubular cell, with some already present chloride. And so, bottom line is, out it goes to the tubular lumen. Some other things that occur within the collecting duct cell, the bicarb that was generated here heads back this way into the renal interstitial fluid, yay. And then one other thing, there's an ATP pump here that's causing potassium to go in and sodium to move out. And that is the complete description of the ammonia buffer system. You can see the benefit within the collecting duct. Bicarb eventually is reabsorbed and the hydrogen moves out and within the collecting duct. So you see the benefit to the body. And then previously you saw in the proximal tubular cell where two bicarbs are generated because of the metabolism of glutamine in that proximal tubular cell. And so those two bicarb ions eventually are reabsorbed by the body, which is another net gain. So that is the description of the ammonia buffer system. Thank you.